Good morning, one and all. Welcome back to the video lecture series, Signaling Systems. This is Dr. P Sreenivasulu. Today we are going to discuss about Laplace transform properties in this time shifting property. Now, Laplace transform of f of t is f of s. Suppose the signal, whether it is a delayed or it is advanced, that is going to be represented mathematically like f of t minus t naught or f of t plus t naught. Here f of t minus t naught means it is a delayed signal. This t naught is a constant, t is a variable. Now, if you apply Laplace transform for this, Laplace transform of f of t minus t naught, it is equal to integral 0 to infinity f of t minus t naught into e power minus st into dt. Now, here the limits are for t and there is a t minus t naught. You assume this t minus t naught, some other variable, dummy variable, that is a tau. Now, if you differentiate this tau with respect to t, d tau by dt is equal to 1. Anyway, t naught is constant, 0. So, finally, you will get d tau is equal to dt. Now, if you want to substitute these limits, at time t equal to t naught, because we are writing for tau limits, at time t equal to t naught, we are going to get tau is equal to 0. At time t equal to infinity, tau is a infinity. Now, the new limits for tau, we can substitute in this. Now, the formula, whatever the mathematical formula, is now going to be changed from 0 to infinity. Instead of f of t minus t naught, we will get here f of tau, and then e power minus s. Instead of t, we are going to write tau plus t naught into, instead of dt, we are going to write d tau. Now, after expansion of this, separate the terms, e power minus s terms, there is a e power minus s tau into e power minus s t naught. This e power minus s t naught is a constant. So, you write outside of the integral, and then again if you write this integration part, 0 to infinity f of t, f of tau, e power minus s tau into d tau. It is nothing but Laplace transform of f of tau. So, Laplace transform of f of tau or Laplace transform of f of t, whatever it is a f of s. Now, the Laplace transform of f of t minus t naught is equal to e power minus s t naught into f of s. So, it is equal to e power minus s t naught into f of s. It is the time shifting property. If we take another property, that is a frequency shifting property. Frequency shifting in S domain. Next property is frequency shifting in S domain. A similar fashion of time shifting, there also, here the frequency shifting means S is equal to sigma plus j omega. So, S is here S domain, or you can also call it as a frequency domain. Now, in the time domain f of t, we are going to take, there is a e power s, e power at multiplication. So, Laplace transform of e power at into f of t. Laplace transform of e power at into f of t. Now, instead of f of t, now we have a e power at into f of t. You write the formula Laplace transform of e power at into f of t is equal to integral 0 to infinity e power at f of t into e power minus st into dt. Now, if you rearrange the terms, f of t into, you write s terms at one place. Now, if you take in that, minus is the common factor, e power minus of s minus a into t dt. And then, if you compare your original formula, if you compare this one with our original Laplace transform formula. What is the original Laplace transform formula? Laplace transform of f of t is equal to 0 to infinity f of t into e power minus st into dt. So after comparing these two formula, now instead of s, because of the scaling of e power at with f of t, s is shifted to s minus c. So it is called frequency shifting property. Next one is another important property. Differentiation theorem. Differentiation in time domain. So f of t is our time domain signal. If we apply differentiation with respect to time, it is nothing but differentiation in time. So you consider this d by dt of f of t, apply Laplace transform for this. Suppose if you do differentiation in time domain, what is the answer in s domain? We are going to observe here. Now you see Laplace transform of f of t, you know as usual the formula integral 0 to infinity f of t into e power minus st into dt. As usual, you know this one. Now, this d by dt of f of t, I am going to rewrite here like f dash of t. F dash of t means first derivative of f of t. So, that is, I am writing Laplace transform of f dash of t is equal to integral 0 to infinity f dash of t into e power minus st into dt. What is this f dash of t? D by dt of f of t. So this f dash of t is d by dt of f of t. Okay. No, no. Actually, yes. And then you write the formula Laplace transform of f of t. The Laplace transform of f of t is integral 0 to infinity f of t into e power minus st. And then you write it is marked as the equation 1. If you apply time differentiation on both sides, time differentiation on both sides, so it is going to get, now I am explaining here a bilateral Laplace transform. Here in this, it is a unilateral Laplace transform. So finally, the time differentiation property is, after differentiating, it is going to get s into f of s minus f of 0. Next, time integration property. This time integration property, we can apply integration of f of t dt, Laplace transform of integration of f of t dt. And then this integration, if you apply this integration for this Laplace transform of 0 to f of t into dt, integral 0 to infinity e power minus st into integral 0 to t f of t dt. You can rearrange these terms 0 to t f of t dt, and then if you apply integration by parts, you will get it is a f of s by s. Now next one is, it is about some properties of Laplace transform. Now, you see a problem on this Laplace transform. Find out the Laplace transform of exponential function which is given as f of t is equal to e power 8. Now here, in the above equation, you observe this, e power 80 means e power 80 into u of t. F of t is equal to e power 80 into f of t. Now, we know about u of t. U of t is equal to 1 for time t greater than or equal to 0. U of t is equal to 1 for time t greater than or equal to 0. And it is 0 otherwise. Now, if we write the Laplace transform of f of t, that is the Laplace transform of e power 80 u of t, integral 0 to infinity e power 80, integral, usually it is from minus infinity plus infinity, e power 80 u of t e power minus st into dt. This u of t is existing from only 0 to infinity, and you substitute that limits, and you can take minus is a common factor, e power minus of s minus a into t. Now, if you apply integration for this, e power minus of s minus a t divided by minus of s minus a, and if we substitute that limits, we will get that answer is a 1 by s minus a. So, whenever we are talking about this Laplace transform, we need to consider the ROC. For what range of values of sigma, or for what range of values of s, this Laplace transform is going to be exist for a particular signal. You see in that equation, after integration, there is a e power minus of s minus a. Suppose this s minus a is greater than 0. If s minus a is greater than 0, then only it is going to be exist. Suppose s minus a is less than 0, it is a negative. Already there is a negative. So negative, negative, positive. So whenever if you substitute the infinity limit, it is not going to be exist. So the corresponding ROC for this particular problem is, the ROC is s minus a must be greater than, s minus a must be greater than 0. It is important. You see here, e power minus 80, e power 80 u of t is 1 by s minus a. The corresponding ROC, region of convergence, s is greater than a. Here, s, sigma plus j omega, but here there is only real part. After comparing that a is belongs to sigma, real part of s. Now, if you draw the s plane, on x-axis, it is real part of s. On y-axis, it is imaginary part of x. So, real part of s is sigma, imaginary part of s is j omega. Now, from that frequency domain or s domain signal, we have a like transfer function 1 by s minus a. So, s minus a, we have a pole at s is equal to a. You locate that pole at s is equal to a. After locating, you draw the ROC. That ROC is S is, real part of S is greater than A. So real part of S means what? Sigma. Entire x-axis. After A, you can apply Laplace transform. But suppose it is real part of S is less than A, the Laplace transform does not exist. Okay? We will see in the next class the remaining problems.